Welcome to the Explainer. Okay, today we're diving into something that literally sounds like it was ripped straight out of a sci-fi novel, but it is happening right now, in real-world labs and hospitals. We're going to explore this unbelievable collision between artificial intelligence and advanced gene editing. It's a breakthrough known as CRISPR-GPT, and as you'll see, this revolutionary combo is already out there saving lives. It's absolutely fascinating. So let's just jump right in. Okay, let's dive into this. Part 1, a historic first patient and the human impact. Before we get totally lost in the weeds of complex data and futuristic algorithms, we really need to anchor ourselves in the human story that started the whole shebang. A 6-year-old child just received the world's very first personalized CRISPR treatment. Just take a second and think about the sheer magnitude of that. We're talking about a massive historic milestone in modern medicine. Imagine being a parent facing a terrifying diagnosis for your kid, only to be offered a uniquely tailored, absolute medical miracle designed specifically for their exact biology. We aren't talking about some broad, one-size-fits-all drug pulled off a pharmacy shelf. This is a completely personalized, genetic cure engineered for one specific human being. Which brings us to the core mystery of this entire breakthrough. How exactly did a computer program just save a life? How do lines of digital code and algorithms running on a server actually translate into a physical, real-world biological cure for a 6-year-old? Keep that question in the back of your mind as we go through the rest of this explainer, because the answer fundamentally rewrites everything we thought we knew about the limits of modern medicine. Section 2, Merging AI and Gene Therapy. This is Stanford's breakthrough. This is where researchers successfully fused two completely different, highly advanced scientific fields that, until now, operated almost entirely in their own silos. Now, what's really interesting about this slide is how we define CRISPR. Think of it as a highly precise pair of biological scissors. They can go deep inside human cells to cut out errors or edit specific sequences of our DNA. But, and here is the massive catch, the human genome is made up of billions of data points, so biological editing is completely useless if you don't know the exact coordinates of where to make the cut. And that's exactly where the second half of our equation comes in, GPT, or artificial intelligence. Think of this AI model as the master digital architect. It can instantly read through those mountains of incredibly complex genetic data, way more information than a human mind could ever process quickly or accurately. The AI analyzes the patient's unique mutation, and then it hands over the perfect, exact blueprints for those biological scissors. It literally tells the CRISPR system exactly where to navigate and precisely where to snip to fix the error. When we put these two technologies together side by side, the difference is just night and day. Historically, developing gene therapies was this incredibly slow, painstaking trial and error process. You had scientists manually figuring out genetic sequences over countless, grueling experiments. But Stanford's CRISPR-GPT, it brings in an AI-guided process to replace years of human guesswork with immediate algorithmic certainty. The AI does all the massive computational heavy lifting, mapping out the precise target almost instantly. It's a total game changer. Moving on to Section 3, Speeding Up the Cure and the Dawn of a New Era in Medical Research. The sheer speed at which this combined tech operates is arguably the most disruptive part of this whole breakthrough. And this brilliantly illustrates the massive drop in research time we're witnessing. What previously took researchers years, or sometimes even decades of grinding lab work, has been wildly condensed down into mere months. It's an absolute mic drop reduction in research timelines. By utilizing an AI architect to design the therapy, we are entirely skipping those long years of trial and error and zooming straight to testing and curing patients. It is a fundamental paradigm shift in how fast medicine can actually move. Because we can now move from years down to months, the horizon of what we can actually treat just blows wide open. This rapid CRISPR-GPT technology could realistically be deployed to target and potentially cure massive, widespread diseases. We're talking cancer, severe inherited genetic disorders, and even incredibly complex neurological conditions like Alzheimer's. Because the AI can so rapidly design custom edits for almost any genetic mutation, the potential real-world applications here are practically limitless. Let's move to and see how this builds into Section 4, the future and its risks, focusing on the ethical divide. Looking at the 5 to 10-year outlook, it's not just a straight path of seamless scientific victories. There are some very serious societal hurdles up ahead. So the crucial point is that we have to look at this impartially. On one hand, the benefits are totally undeniable, right? Miraculous cures for terminal patients and lightning-fast research cycles that will undoubtedly save countless lives. But on the flip side, the ethical risks drawn from the source material are honestly pretty staggering. Developing highly personalized AI gene therapies requires immense computational power and cutting-edge facilities, and that is incredibly expensive. There is a very real risk that this creates a severe wealth divide in medicine, leading to a profound lack of accessibility for the average person. We could literally be looking at a reality where the ultimate cure exists, but only a tiny, tiny fraction of the global population actually has the resources to get it. Which leaves us with a really lingering, provocative thought. In the next 5 to 10 years, will personalized AI medicine be considered a universal human right? Or is it just going to become a brand new luxury for the ultra-rich? As this tech rapidly evolves from saving a single 6-year-old patient to potentially treating millions of people, it's a question of healthcare equality our society absolutely has to answer. Keep asking those big questions, and hey, thank you so much for exploring this explainer with me today.